Tucked away in the constellation Libra, 190 light-years from Earth, is a stellar anomaly, an ancient mystery so baffling that it forced scientists to question everything they thought they knew about our universe. At first glance, this star, officially known as HD 140283, doesn't look particularly special. It isn't unusually large or freakishly bright, and it generally conforms to widely accepted models of stellar evolution. However, in the 2000s, this apparently unassuming star sent the entire scientific world into turmoil. Astronomers had long suspected that HD 140283 was old, thanks to its unusual composition, more on that later, but when they first attempted to determine exactly how old, the number they came up with was shocking. HD 140283 wasn't just old, it was impossibly ancient. And I'm not using the word impossible lightly. According to astronomers' careful calculations, this strange star was 16 billion years old. To put that in perspective, it would be 2 billion years older than the universe itself. This is the story of the star that shouldn't exist, the story of HD 140283, better known as the Methuselah star. Now, people often think that performing at the highest level requires stress, but that's not true. 5 years ago, Magic Mind set out to create a drink that could boost mental performance consistently, without downsides like overcaffeination, jitters, or anxiety. Magic Mind contains adaptogens like ashwagandha, which help combat stress, and organic lion's mane mushrooms to boost cognitive power. At the start of this year, I tried Magic Mind for the first time, and I found it so effective that I've continued to take it every day since. Magic Mind is different from others because it's 100% safe. All ingredients are third-party tested and sourced from the best suppliers. It's not a quick fix, but rather a long-term solution. Some ingredients take 3 to 4 days to reach their full effect. After my first week, I still remember feeling an increase in attention each day. Magic Mind is doctor-validated, created with a scientific advisory board of doctors and medical researchers, and developed over 10 years. For the next 10 days, you can get 20% off a one-time purchase at www.magicmind.co. Thanks to Magic Mind for sponsoring this video. The early universe was a very different place from the one we live in today. After the Big Bang, existence was essentially a hot soup of protons, neutrons, and electrons. Over hundreds of thousands of years, things cooled down enough for the first atoms, mostly hydrogen and helium, to form. Around 150 to 200 million years after the Big Bang, these particles came together to form the first stars. Somewhat confusingly, these first stars are called population 3 stars. We've never directly observed one, but scientists believe they were massive, perhaps 60 to 300 times the size of our Sun, and extremely hot and luminous. Counterintuitively, larger stars have shorter lifespans because they burn through their fuel more quickly. Population 3 stars likely exhausted their fuel in just a few 100 million years, ending their lives in spectacular supernova explosions. These explosions spread newly formed heavy elements into the universe. The stars that formed from this material are called population 2 stars, and they contain small amounts of heavy elements, unlike their predecessors. HD 140283, the Methuselah star, is a population 2 star, and scientists first realized its age in the 1950s when spectroscopic analysis revealed its low heavy element content. For example, it contains just 0.4% of the iron found in the Sun, indicating it formed before iron was abundant in the universe. In 2000, astronomers used data from the European Space Agency's Hipparcos satellite to estimate HD 140283's age. They calculated it to be 16 billion years, 2 billion years older than the universe. This discovery rocked the scientific world because it seemed to contradict everything we knew about cosmology. By the turn of the millennium, the Big Bang theory had become the dominant model for the universe's origin. If HD 140283 was truly older than the universe, it could potentially invalidate the Big Bang theory. The star soon gained the nickname Methuselah, after the biblical figure said to have lived 969 years. The question remained, How could a star be older than the universe? This has led some astronomers to propose that the universe might be older than currently estimated, potentially around 26.7 billion years. The question now becomes whether the Methuselah star provides further evidence supporting this hypothesis of an older universe. The answer, however, is not straightforward. While the age of the universe is still debated, the estimate of 13.8 billion years is robust, supported by multiple independent observations. One of the strongest pieces of evidence for this figure comes from analyzing the cosmic microwave background radiation, which provides insights into the universe's early conditions and subsequent evolution. In 2013, a team of astronomers from the Penn State team revisited the observational data of HD 140283, utilizing updated measurements from the Hubble Space Telescope. Their findings revealed a new age estimate of 14.46 billion years, which, while lower than the original estimate, still placed the star older than the universe itself. In subsequent years, more studies emerged, each employing better data and refined models to narrow down the age of the Methuselah star. A paper published in 2014 revised the estimate down to 14.27 billion years. In 2021, that figure was further adjusted to approximately 12 billion years, comfortably younger than the current estimate of the universe's age. As we continue to explore the universe, it is essential to acknowledge that our understanding is always evolving. The cosmos is vast and mysterious, and it is inevitable that some of the assumptions we currently hold will be proven incorrect. This constant evolution of knowledge underscores the nature of scientific inquiry. The age of HD 140283 may ultimately be refined further, and its classification could change as new techniques and technologies emerge, shedding light on this ancient celestial body. Of course, the answer is that it can't. Either the Methuselah star is younger than it seems, or the universe is older. The universe is thought to be about 13.8 billion years old, based on various observations, such as the cosmic microwave background and Hubble's law. Despite this, some believe the universe could be older. A 2023 study proposed it might be 26.7 billion years old, nearly twice the current estimate. But this remains speculative. In 2013, a team from Penn State University attempted to resolve the Methuselah star mystery. They re-examined the data, using more accurate measurements from the Hubble Space Telescope. The new estimate brought the star's age down to 14.46 billion years, which, while still older than the universe, was within the margin of error. Over the past decade, further studies have continued to refine the star's age. By 2021, estimates placed it at around 12 billion years, well within the universe's age. While the Methuselah star may no longer be a universe-breaking anomaly, it remains one of the oldest known stars and a testament to how much we still have to learn about our cosmos. So, while this star didn't break our understanding of the universe, it has certainly shaped it. Our journey to understand the Methuselah star continues to remind us that science is ever-evolving, and we are always uncovering new mysteries about the universe.